In this video, I want to talk about the probability mass function, which we sometimes abbreviate by PMF. The probability mass function is just a list of probabilities, denoted by P of x, for each value of x. So for every possible thing that could happen, we list out its probability. As an example, we have a simple random sample of size 3 that is drawn from a batch of 10 product items. We know that 3 of the 10 items are defective, so we want to find the PMF of the random variable x, which is the number of defective items in the sample. And I'm going to do this with a table. So we could have 0 defective items, we could have 1, we could have 2, or we could have 3. Let's think about the probability that we have 0. Well, we would need to draw all non-defective items. We know there are 7 non-defective items, and we need to choose 3 of them since we have a sample of size 3. All of the possible options that we could pick, well, there are 10 items that we are going to choose 3 of. So this would determine the probability of drawing 0 that are defective. And if we work this out, we get roughly 0.292. So the probability of drawing 0 defective would be 0.292. Next, let's look at the probability that 1 is defective. Well, that means out of the 7 non-defective, we're going to need 2 that are not defective. And out of the 3 that are defective, we need to pick 1 of them. And our denominator is still the same. We have 10 that we're picking 3 items from. And if we work this out, we get 0.525, so the probability of drawing 1 defective would be 0.525. Next, we'll do 2 defective. If 2 are defective, then there's 1 that's not, so out of the 7 that are not defective, we need to pick 1 of those. And out of the 3 that are defective, we need to pick 2. Out of a total of, we have 10 items, and we are picking 3. And if we work this out, we get 0.175. So the probability of selecting 2 defectives would be 0.175. Finally, let's look at the probability of selecting 3 defectives. We have 3 defectives, we need to pick all 3 of them. Out of a total of that, we have 10 items that we just need to pick 3 of. Working this out, we get approximately 0.008, so that would be the probability of selecting 3. So now this table right here is our probability mass function. Let's do one more. This time I want to roll 2 dice separately, and I want to find the probability mass function of the experiment that records the sum of the 2 rolls. This time I'm going to do my table horizontally. All the possible sums of 2 rolls would be the numbers 2 through 12. Let's think about 2. The only way to roll a sum of a 2 would be to roll a 1 and a 1. So there is one way to do this, out of a total of 36 ways to roll a dice. What about a 3? Well, we could do a 1 and a 2, or a 2 and a 1. So now there are 2 ways out of a total of 36 ways to roll a dice. For 4, we could have 1 and 3, 2 and 2, or 3 and 1. So there's 3 out of 36. For 5, 1 and 4, 2 and 3, 3 and 2, 4 and 1. So there are 4 out of 36. For 6, we have 1 and 5, 2 and 4, 3 and 3, 4 and 2, and then 5 and 1. So now there are 5 out of a total of 36. 7 has 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, or 6 and 1. A total of 6 ways. For 8, I can't do a 1 and a 7 since 7 is impossible on a dice. The first thing I can do is 2 and 6. 3 and 5, 4 and 4, 5 and 3, or 6 and 2. So there are a total of 5 ways to roll an 8. For a 9, we would have to start with 3 and 6, 4 and 5, 5 and 4, or 6 and 3, so there are a total of 4 ways to roll a 9. For a 10, we have 4 and 6, 5 and 5, or 6 and 4, so there are 3 out of a total of 36. For 11, we could have a 5 and a 6 or a 6 and a 5, so 2 out of 36. And then finally, the only way to do a 12 would be a 6 and a 6, so 1 out of 36. So this would be my probability mass function for the sum of 2 die rolls.